Hi folks, today we are going to talk about the product and quotient rules. We are still learning more derivative rules. When we have this function that we want to find the slope of or the rate of change, we need to know how to take the derivative. So far we've covered the power rule, which gets used in everything else. We've talked about the derivative of sine and cosine. We've discussed the derivative of the natural log of x and e to the x, and I think we had an a to the x in there as well. So a few more to go. The product and quotient rules get used quite frequently. For the warm-up, we want to find the derivative of 3x squared times 5x plus 1. Now, right now, these two items are being multiplied, so your only choice is to turn it into something that we can use the power rule for. We've got a whole bunch of algebra rules that we know. So if I have 3x squared times 5x plus 1, what can we do with the 3x squared? You can distribute it. So distribute the 3x squared through the 5x plus 1. So 15x cubed plus 3x squared. All we've done is algebra. Now to find the derivative, we have the power rule. 3 times 15 in the front makes it 45x squared plus 6x. There's your derivative. Good job. Isn't that better than the limit as h approaches 0 and all that other stuff? Yeah. All right, so what I have for you now is the product rule. And the product rule says, if I find the derivative, I'm gonna write this twice, of f times g, it is really f times the derivative of g plus g times the derivative of f. So shorthand notation, d dx of f times g is really, we say fg prime plus gf prime, or it's the first times the derivative of the second plus the second times the derivative of the first. So let's revisit the warm-up, and this time we're going to use the product rule. So let's use a couple colors in here. This term, our 3x squared, is going to act as the f, and then 5x plus 1 acts as the g. So for the product rule, I'm going to use my notation above. It's going to be fg prime plus gf prime. So if I just put in the f term, that's 3x squared. G prime is the derivative of that second term, so the derivative of 5x plus 1 is 5. Remember, we use that power rule everywhere. G is 5x plus 1. We just write it in as is. And f prime is the derivative of the first term. The derivative of 3x squared is 6x. All right, that, my friends, is the calculus step. Anything beyond that is going to be the algebra. So we're just going to clean up the algebra a little bit. I'm going to scooch this up. We have 3x squared times 5. Well, that's 15x squared. And then over here, I'll distribute the 6x. So I've got 30x squared plus 6x. Now I see some like terms. This becomes 45x squared plus 6x. That is my derivative. Do you have to simplify it? Yeah, you do. But here's what I want to show you. 45x squared plus 6x. Wait a minute. Check out our warm-up. Let's make that bigger. There it is, 45x squared plus 6x. We got the exact same thing. So sometimes it's easier to do algebra first. Sometimes it's easier to do the product rule. And sometimes you have no choice but to use the product rule. And I'm looking ahead at example 3. With that e in there, you have to use the product rule. But example 2, there's a lot going on. You technically could FOIL this out first. However, you've got a lot going on with negative exponents and fractional exponents. So we're going to use the power rule because that's what we're practicing here. So dy dx, I'm going to write the rule a few times just until it's ingrained in my brain. fg prime plus gf prime. So dy dx is equal to x to the negative 1 plus 2. G prime, now these fractional exponents, nobody ever likes them, but bring your 3 halves to the front, x, and 3 halves minus 1 is really 1 half, and then the derivative of 1 is 0. plus the second one is x to the 3 halves plus 1 times the derivative of the first term is negative x to the negative 2. The derivative of 2 is 0. So there you go. There's your product rule. You do want to simplify this algebraically. So when we distribute 3 halves x to the front here, this will be 3 halves x to the negative 1 half. Remember, you're adding the exponents, plus 3x to the 1 half, because 2 times 3 halves is really just 3. Distribute this one through, and we'll get a negative x. 3 halves and a negative 2 is a negative 1 half, minus x to the negative 2. And I see some like terms in here. I see a negative 1 half and a negative 1 half exponent. So dy dx is going to be 1 half x to the negative 1 half plus 3x to the 1 half minus x to the negative 2. And there's our solution. Excellent. Had you FOILed that out first and found the derivative with the power rule, you would get the same thing. Example 3, find ddx or ddt, excuse me, of t squared e to the t. Remember, these are being multiplied. So if I want dy dt, t is our independent variable here, of t squared e to the t, remember my formula, fg prime plus gf prime. So f is t squared, g prime is the derivative of e to the t. I know we just learned that in our last lesson. It's e to the t, plus g is e to the t, and f prime is the derivative of the first term, which would be 2t. A couple things, the derivative of e to the t of all the derivative rules that we learned, that is the only one that stays exactly the same. They will all the other ones will change in some manner or another. The other thing students ask me is, how do I simplify this? Well, you just can really rewrite it. So you can call it e to the t, t squared, e to the t times 2t. What you can't do, and I've seen some scary things, you can't combine this t and this 2. There's nothing to do there. You could factor a little bit. I kind of like to pull out the e to the t and call this t squared plus 2t. And yes, technically there's another t that comes out, e to the t plus 2. So depending on what you're doing, any one of those versions might be helpful. If I were to set it equal to 0, this might be the version that I like. If we had to find the derivative again, this might be the version that I like. If I just had to write out the answer, maybe it's that first one. So I know you're always looking for that one correct answer, but sometimes there's multiple forms of the correct answer. So there you go, that's the product rule. Quotient rule, that takes care of things being divided. Now, if I'm looking for the derivative of f over g, this one's a little bit longer. I'm just going to jump right into that shorthand notation. It's g f prime minus f g prime over g squared. G is on the bottom, always on the bottom. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, let's give it a go. Example 4, find y prime if all of that is true. Now, technically, you could go through some long division, but we don't want to do that. We'll save that for another day. We're going to use the quotient rule. So y prime is, now I'm going to write out the formula, g f prime minus f g prime all over g squared. F is on the top and g is on the bottom or in the denominator. So g is x plus 5. F prime is the derivative of the numerator, so that's 3x squared plus 4x. The derivative of 1 is 0. Minus f, which is x cubed plus 2x squared minus 1. And g prime is the derivative of the bottom, so the derivative of x plus 5 is 1. All over g squared, which is x plus 5 squared. Okay. That step is the calculus, filling in all the pieces into the formula, into the quotient rule. That's the calculus step. Anything that comes after that is algebra. Now, can you leave your answer like this? No, you want to clean it up a little bit. Mrs. Charnley, this is the question I get all the time. Mrs. Charnley, can I cancel out the x plus 5 and the x plus 5? No, 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 you can't. You cannot do that. You would have to have an x plus 5 factored out of both pieces in the numerator. And in truth, this is what I tell students. If you could have canceled them out, they would have canceled them in the original formula, but they didn't do that. So be careful of your algebra rules. And I know for some of us, it's been a long time since we've had to worry about that. So do not cancel inappropriately. But I am going to FOIL. So I've got 3x cubed plus 4x squared plus 15x squared plus 20x. Now I'll distribute that negative sign, negative x cubed minus 2x squared plus 1 all over x plus 5 squared. I would not bother foiling the denominator. Do not foil. Do not foil. The reason is, remember when we were looking at discontinuities, we wanted to know when we divide it by 0? Sometimes that still happens. So if it's all foiled out, it's tough to tell where you have 0 in the denominator, but if you leave it in the factored version, it's much easier. So don't spend your time foiling the denominator. Numerator, yes. Denominator, no. Now, if I come through here and combine like terms, I see a 2x cubed. We got that. We got that. If I go to the x squareds, I've got a 19 minus 2, 17x squared. So we took care of that and that and that. And then the x term is just x plus 1 all over x plus 5 squared. All right. One quotient rule. Okay. And example 5, here's another one. Find f prime of x if f equals x squared minus 1 over x to the 4th plus 1. So f prime of x equals the bottom times the derivative of the top minus the top times the derivative of the bottom. Squeeze that in there, all over the bottom squared. Remember, you cannot cancel the x to the 4th plus 1. It doesn't work. But let's distribute. I've got 2x to the 5th plus 2x minus 4x to the 5th plus 4x cubed all over x to the 4th plus 1 squared. What else? We got some like terms up here. So this is negative 2x to the 5th plus 4x cubed plus 2x all over x to the 4th plus 1 squared. All right, there we go, quotient rule. And I think that's it for examples for today. Be smart about your algebra. Be very, very, very smart about your algebra. I just want to note one other thing. When I'm just thinking of the mistakes that I've seen happen over the years. When you look at the quotient rule, the denominator must come first. Bottom derivative of the top minus the top derivative of the bottom over the bottom squared. It must come first. When you look at the product rule, technically you can switch the order, right? Because it's addition and multiplication, we've got that commutative property where order doesn't matter. So you could technically start with the denominator on the product rule. This is the way that I had it memorized. That's what it used to be in our textbook. I think if you chat with Mrs. Oakes, I think she does it in the other direction, but it doesn't matter. They both go in the same direction. So, or in the same, you get the same result. So product rule, that order doesn't matter as much. With the quotient rule, it absolutely matters. You must start with the denominator. So that is a mistake that I see. All right, good luck. Definitely practice these out. They're very, very, very important. Add them to that golden ticket. I got it into the syllabus section, just come for resources, and that'll help you along the way. Remember to reach out when you have questions.